Assalamu alaikum. My name is Rimsha Majeed. My student ID is at 12. I am a department of the MS Chemistry. My presentation topic is a surface characterization technique. Now I move forward. The material characterization technique. The material characterization is depend upon the two main aspects. First one is accurately measure the physical and the chemical properties of material, and second one is accurately measure the structure of material. That is on the atomic level structure and the microscopic level structure. Material characterization is also identify the composition and structure of material, including the defect, and the composition and the structure of the material also depend upon the electrical, chemical, and the magnetic properties of the material. The material characterization is also depend upon the properties of material, and they also depend upon the manufacturing process that are identified by the production and the parts of the components. The composition and structure of the material that can be characterized by the identified. There are the three main types that can be characterized. First one is a topography के elemental composition के bulk structure and the composition के. Topography is defined as the total local deviation of the surface from the perfectly flat surface. Topography surface can be characterized by the three main techniques SEM, AFM and the SEM. SEM is abbreviated as the scanning electron microscopy, and the AFM abbreviated as the atomic force microscopy, and the STM is abbreviated as the scanning electron microscopy. Elemental composition is a type of the chemical composition that in which the material can be identified by the EDA, EDX, XEDS, and the XPS. EDS is abbreviated as the energy dispersive spectroscopy, and the EDS is the energy dispersive X-ray spectroscopy, and the XPS is the X-ray photo electron microscopy. And the last part of the material characterization that can be identified is a bulk structure and the composition. Bulk structure and the composition is the analysis by the TEM and the EBST. TEM is abbreviated as the tuning electron microscopy. EBST is abbreviated as the electron backscatter diffraction. Material characterization is also depend upon the material properties that we are characterized, and understand how the properties can be identified, understand how the instrument or the equipment for investing the material properly work. The surface microscopic technique is in which the microscopy is a technique view the material on the scale is a smaller than that can be resolved by the unaided human eye. Main type of the microscopy, three main types of the microscopy: electron microscopy, and the scanning probe microscopy. Optical microscopy is used by the visible light only, and the electron microscopy has the two main types: transmission electron microscopy and the scanning electron microscopy. Scanning, third one is a scanning probe microscopy. They have also the two main types. First one is a scanning tunneling microscopy, and the second one is a atomic force microscopy. Characterization techniques which probe and the map. The characterization technique that which can be a probe and map. These techniques can be used the photon, electron, ions, physical cantilever probes to gather the data about the sample structure on a range of the length scale that is also applicable on the surface and the subsurface. These techniques can use the photon, electron, ions, and the scintillated probe. The techniques that can be a material characterized First one is the transmission electron microscopy. के transmission electron microscopy is first developed by the Max Knoll and the Ernest Ruska in Germany 1931 के. The transmission electron microscopy is a developed with a pattern exactly on the light transmission microscope, except that the focus the beam of electron is a used incident of light see through the specimen. के. The procedure of the transmission electron microscopy. The transmission microscopy is a microscopy technique where the beam of electron is transmitted through the ultra thin specimen, interacting with the specimen as it passes through. An image is a form from the induction of electron transmitted through the specimen. Image is a magnify and focus on the imaging device, such as the fluorescent screen or a layer of the photographic film, are to be detected by the sensor, such as the CCD cameras. Transmission electroscopy has the resolution power is a 0.2 nanometer and the magnification power is a 5 lakh S. This is a diagram of the transmission electron microscope. The source is a filament gun that produce the electron that passes on the strike on the condenser ions and then pass by the specimen and then fall on the specimen and that magnify the image detect the electrons या ions on the fluorescent screen और photographic film the transmission electron microscopic working the main component of the transmission electron microscopy is a first condenser virtual source that is a filament gun and the first condenser lens, second condenser lens, objective lens first intermediate lens second intermediate lens and the projector lens The right hand side of the transmission electron microscope is a condenser aperture, objective aperture, and the detected area aperture. And the last one and the bottom of the transmission electron microscope is a phosphor. And the sample is a place between the second condenser lens and the objective lens. Is a different component of the transmission electron microscope. They are the 14 component of the transmission electron microscope. First one is a high tension cable second one is a staple motion for the centering the electron beam and third one is electron emitter condenser is a fourth one and the five is a pressure controller and the five is a pump lead six one is a specimen holder objective lens or projector lens optical lens canometer vacuum and the magnification control and the focusing control is a two diagrams of the two diagram of the transmission electron microscope the two viruses are detected by the transmission electron microscope. The one is a poliovirus and the another is a streptococcus aureus that can be magnified or detected by the transmission electron microscope. Scanning electron microscopy second one is the scanning electron microscopy the scanning electron microscopy was first developed by the Manfred von Adrena in 1938 It is a first scanning electron microscopy and is a first commercial instrument around the 1965 and the late development in the scanning electron microscopy because the scanning in a beam of the electron across the sample procedure of the transmission electron microscopy. The scanning electron microscopy is a type of the electron microscopy that images the sample by scanning with the high energy beam of electron in a scan pattern. The electron interact with the atom that make up the sample, producing the signal that contain the information about the sample surface topography composition and the other physical or chemical properties Characterization that can be view has a view on the स्कैनिंग इलेक्ट्रॉन माइक्रोस्कोपी के, टोपोग्राफी के, मॉर्फोलॉजी के, कंपोजिशन के। टोपोग्राफी, the object or the feature of the surface that can look like the texture, direct reaction between the feature and the material properties के। मॉर्फोलॉजी यानी शेप और साइज, शेप एंड साइज ऑफ द मटेरियल that make the object and the direct reaction between the structure and the material properties के। composition के, the element and compound that object is a composed of या made of, relative amount of the and the relative amount that the direct reaction between the composition and the material properties के। crystallography information, how the atom are arranged in an object, direct reaction between these arrangement and the material properties के। magnification and resolution power of the scanning electron microscopy, the magnification power of the scanning electron microscopy is of 500 ks and the resolution power is only 1.5 nanometer के। how the scanning electron microscopy work can component of the scanning electron microscopy, the three main component of the scanning electron microscopy. First one is a electron optical column के। second one is a vacuum system के। second one is a vacuum system okay, and the third one is a detector and display के। the first component, that is a electron optical column के, that is a consist of the electron के that produce the electron के, and the second one is a magnetic lens के that magnify the beam के, and third one is a magnetic coil के that control and the modify the beam के, and the fourth one is a aperture के that define the beam prevalent the electron supply के। The vacuum system consists of the chamber which hold the vacuum pump to produce the vacuum के, and the valves to control the vacuum gauges to maintain the vacuum के। The last one is a detection and display, that is a consist of the detector which collect the signal के, and the electronics which produce the image from the signal के। Instrumentation of the scanning electron microscopy के, the virtual source at the top represent the electron gun that producing a monochromatic electrons के। Monochromatic electrons that the monochromatic electron that are the only passes the single wavelength of the beam के। And the beam, the steam is a condensed by the first condenser lens can usually controlled by the coarse probe current knob के। This lenses are used to both from the beam and they limit the amount of the current in the beam के। It work in a conjunction with a condenser aperture to eliminate the high angle electron from the beam के। Then we move forward. The beam is then constructed by the condenser aperture, usually not a user selectable, eliminating some high angle electrons came. And the second condenser ions form the electron into a thin, tight, coherent beam and usually controlled by the fine probe current knob came. The fifth function is the user selectable objective aperture further eliminate the high angle electrons from the beam के, and the sixth component function is the set of the coil that scan or sweep the beam in a grid function के, like a television dwelling on a point for a period of the time determined by the scan speed usually in a microsecond range के। The seventh component is a function has the lens के objective के that focus the scanning beam के onto the part of the specimen desired के। The eighth component function is when the beam strike on the sample के and dwell for a few microsecond के, intrusion occur inside the sample and are detected with a various instruments के। Ninth component of the function is before the beam moves to its next developed point, these instruments count the numbers of the electron interaction and they display the pixel on the CRT whose intensity is determined by the number game. The more reaction, that brighter the pixel, and the less reaction, lighter the pixel. The 10 major, the last component of the scanning electron microscopy, the process are repeated until the grid scan is a finish and then repeated. The interpreter can be scanned the 30 times or a second. A diagram of the scanning electron microscopy, and the component that is present in the scanning electron microscopy. At the top the electron gun is a present. Second one is a gun element control के. Third one is a pneumatic air loop valve के. Fourth one is a condenser lens. Five is the objective aperture scanning coil के. And the sixth one is the objective lens. And the seventh one is a motorized stage. And the last one is a sample chamber के. There are the three diagram of the scanning electron microscopy that are detected or magnified by the scanning electron microscopy. First one is a spider, and that is a coated in a gold. And the view has the scanning electron microscope with the help of the scanning electron microscope. And the second one is a bacteria E. coli, is detected or magnified by the transmission electron microscope. And the third one is a Salmonella typhimurium, that invading the culture human cells and that is also shown by the transmission electron microscopy The electron-solid interaction in a transmission electron microscopy when the electron beams strike on the sample, the large number of these signals are generated or produced. That signal may be secondary electron, X-rays, backscatter electrons, etc. When the incident of the electron beam is a fall on the sample, the various number of the signals are produced. They are the backscatter electrons, they are the elastical scatter electrons, they are the inelastic scatter electrons, and they are the unscattered electron that is produced from the transmitted electrons. The types of the signal that can be categorized is a 2K. One is a electron signal and the second one is a photon signal. Scanning tunneling microscopy. The scanning tunneling microscopy is first developed by the great Binning in and the Hammad Roher. The inventor deserved a Nobel Prize for the physics in a 1986 The scanning electron microscopy is a magnificent microscopy ever built. The scanning tunneling microscope is an electron microscopy that transmits the three-dimensional image of the electron around the nucleus. The scanning tunneling microscopy allows the inspection of the properties of the conductive solid surface at an atomic size. It is very important technique in determining the atomic structure and the electron state of the surface under investigation. Surface can be viewed at the atomic size thanks to the high resolution that scanning tunneling microscopy has. 5 basic components. First one is a metal tip. Second one is a piezoelectric scanner third one is a current amplifier fourth one is a bipotential state basis and the fifth one is a feedback loop The basic component of the scanning tunneling microscope, the main component is a piezoelectric tube with the electrodes that control the piezoelectric instrument that control the voltage we are take the sample and then we put a piezoelectric tube with the electrons that fall on them and we are finally detected the data processing and the display on the other side of the diagram, the atomic structure of the silicon surface that is detected by the scanning tunneling microscopy. Tunneling effect. The basic of the scanning tunneling microscopy is the quantum tunneling theory के. According to the quantum tunneling theory, when the energy of the electron exceeds to the total energy, it can penetrate the region which are impossible according to the classical physics. So it can be a tunnel. And just has it is a show in a diagram that one person that the exceed the total energy, then it is not impossible, and it can be impossible that can be impossible to according to the classical physics game. In other words, if the two connectors are about closer to each other, 10 ak are the more, and the potential difference are created between them, the electron are likely to tunnel through the potential barrier between the two conductors game. Working principle of the scanning tunneling microscopy game is a scanning tuning microscopy have a good resolution, are considered to be 0.1 nanometer lateral resolution के and 0.01 nanometer depth resolution के. The scanning tuning microscopies are based on the concept of the quantum tunneling and which fall under domain of the quantum mechanics के. Quantum mechanics matter has the both particle as well as the wave nature के. Wave-like properties of the electron permit them to tunnel beyond the surface of the solid into the region of the space that are the forbidden to them under the rule of the classical physics. Smaller the barrier width, more precisely wave can be passed through. And larger the barrier width is a less precise and the wave cannot pass through. The scanning tuning microscopy make us the use of the extreme sensitivity to the distance. The sharp tip of the tungsten needle is a positional a few angstrom from the sample surface. Second one is a sample small voltage applied between the probe tip and the surface, causing the electron to tunnel across the gap. In a metals, electron appear to be freely moving particle, that this is a illusory. In a reality, the electron move from the atom to atom by tunneling through the potential barrier between the two atomic sites. Piezoelectricity. Piezoelectricity is defined as the means to the squeeze or press are the electrics and the electric, which means the amber are the ancient source of the electrical charge. Piezoelectricity is mainly the source of the electrical charge. The electrical charge that accumulate in a certain solid material can respond to the applied mechanical stress, usually by the change of the polarization power, etc. It provides the variation in a direction with a detail about the origin. It also provides the piezoelectricity is also detail about the orientation and also that and also explain the wave function in a electron and a finite tunneling connections are generated by applying the bias voltage between the tip and the sample. Tunneling current is generated. Two modes of the working of the scanning tunneling microscopy constant height mode and the constant current mode The constant height mode, the voltage and the height are both held constant will the current changes to keep the voltage from changing This lead to an image made up of the current changes over the surface, which can be treated by the chart dynasty It is faster, has the piezoelectric movement, require the more time to register the height change in a constant current mode and then the current change in a constant high mode The constant current mode, second one is a constant current mode The contrast on the image is due to the variation in a chart dynasty feedback electron adjust the height by the voltage and the piezoelectric height control the mechanism Last one is a AFM, is abbreviated as the atomic force microscopy History the atomic force microscopy is first developed by the Binning and the Cute in 1986 the first time the idea of the AFM is also introduced by the Binning and Cute which use the ultra small probe tip at the end of the cantilever Definition of the atomic force microscopy is a type of the scanning probe microscopy which demonstrates the resolution on the order of the fraction of the nanometer, more than the 1,000 times better than the optical diffraction limit. The main principle of the AFM, first one is a surface sensing के, second one is a imaging के, third one is a detection method के. The principle of the AFM, first one is a surface sensing के. The atomic force microscopy uses the cantilever with a very sharp tip के, to scan the sample surface or structure के. As the tip approach the surface, the close range attractive force between the surface and the tip causes the cantilever to deflect towards the surface. Okay. However, the cantilever is even close to the surface, the tip makes the contact with the increasing the repulsive force and cause the cantilever to deflect away from the surface. Okay. Second one is the imaging. AFM image the topography sample by the scanning cam. By scanning by scanning the cantilever over a region of the interest. The rise and lower features and deflection of the cantilever, which is monitored by the PSPD. The AFM can generate the accurate topography map of the surface feature or surface structure. Detection method. The laser beam is used to detect the cantilever deflection towards or away from the surface or structure. By reflecting any incident beam of a flat top of cantilever, any cantilever deflection will cause the slight change in the direction of the reflected beam. The positive sensitive photodiode can be used to track these changes. AFM tip passes over a rise surface. Features के the resulting cantilever deflection is recorded by the PSPD. The diagram show that the tip that fall on the electrons के, the photo detector is also present. Laser that fall on the tip के, sample के, substrate के, piezo scanner and the feedback control mechanism के. The graph is also shown the right hand side of the diagram के, the x-axis and the y-axis. Probe distance from the sample के, and the force on the right hand side के. is a repulsive regain के repulsive regain. Tip is a pull towards the surface is a attractive regain के, and the tip is a hard contact with the surface is a repulsive regain के. And the normal and the straight graph show that the tip is a far from the surface के, no deflection is occur के. The effect of the dilute acid pre-treatment under the different temperature. XY piezo, Z piezo, and the force transducer that is fall on the sample. X-rays electronics compare set force and feedback controller that form the imaging. AFM instrumentation के, the main component of the atomic force microscopy are the microscopic stage के, control electronics के, and the computer के. The microscopy stage moving the AFM tip, sample holder, and the force sensor that controlling the AFM tip के, sample holder and the force sensor के. The control electronics control the optical microscope के, vibration control. And the computer is electronics usually takes from the large box interface to the both the microscope stage and the computer के. The basic concept of the atomic force microscopy. The piezoelectric transducer moves the tip over the sample surface. The force transducer senses the force between the tip and the surface, and the feedback control feed the signal from the force transducer back in a piezoelectric to maintain the fixed force between the tip and the sample. The force transducer in the diagram showed at the transducer data probe on the sample के, amplifier is also connected, and the signal that show by the graph के. It may be a constructed that measure the force as low as the piconewton के. RAP summary of the nature and the pre-treated plant cell wall. The graph is also show that the plant cell wall pre-treated by the natural RAP summary के यानी one-sided the x-axis and y-axis के DAP is a delignified and the DAS is a delignified and the DACG is a delignified. It is all over the topic of the surface characterization technique. Thank you.